About a very important estimation called cholesterol estimation. Cholesterol is a lipid, simple lipid and derived lipid. Why both? I will tell you just now. This estimation is important in relation to diagnostic significance of heart ailment, especially atherosclerosis. And this is an important estimation in biochemistry in examination also. Alright? And this is the tray which talks about the cholesterol estimation. We will be providing you with this tray in the examination also, where the procedure will be given to you. This procedure is simple, which is shown here. The additions, the element to be added, 3 test tube, and what you add in the test tube, everything is given here. This will be kept in the tray. So what you will have to probably answer in the question is the principle of the estimation. What is the clinical significance of cholesterol? All these questions become very important, right? Procedure is important, how you do it is important, but more important than that is the diagnostic significance of cholesterol. So first let us understand what cholesterol is all about. So cholesterol is a perhydroxycyclopentanophenoxylate ring like this. It has got number of CH3 molecules. It has got an OH at carbon atom number 3. So if it's got an OH, it is an alcohol. If it is an alcohol, it can be esterified with a fatty acid. So when I esterify this with fatty acid, this free cholesterol becomes esterified cholesterol. And this fatty acid esterifies this cholesterol. Where is this fatty acid coming from? This fatty acid is coming from, this fatty acid is mostly PUFA, polyunsaturated fatty acid, which is coming from lecithin. The C2 of the phospholipid lecithin carries this PUFA, and the enzyme which does this transfer of this acyl group from lecithin to cholesterol is called as lecithin cholesterol acyl transferase, LCAT. You must have heard this all in the theory of lipid metabolism. And this is present in HDL. High density lipoprotein carries this LCAT, and therefore HDL is responsible for the esterification of cholesterol, doesn't allow the cholesterol to remain in the free form. It's always esterified. So in the blood, when we are taking the blood sample for estimation of cholesterol in the serum here, the cholesterol estimated is in the esterified form, cholesterol ester. So what we will do is we will take the serum in the test tube and add an enzyme cholesterol esterase. When I add the enzyme cholesterol esterase, esters will be split into free cholesterol and fatty acid, free fatty acid. This free cholesterol in the same reagent has got an enzyme oxidase, which will convert this cholesterol into H2O2. This H2O2 will be then converted to nascent oxygen, which will react with the antipyrine solution to give you a red color. This is the principle. Look here. The principle is cholesterol ester by the enzyme esterase gets free cholesterol and free fatty acid. By the enzyme oxidase, the free cholesterol is converted to H2O, and then H2O2 is converted to nascent oxygen, and this nascent oxygen is by the enzyme peroxidase. Catalase and peroxidase, if you remember, can convert H2O2 to nascent oxygen, and this nascent oxygen will react with amino antipyrine, which we saw in glucose estimation also, to give a red colored complex or a pink colored complex depending upon the concentration of the cholesterol, and this can be measured in a colorimeter. So basically the principle is very simple. Cholesterol ester is broken down to free cholesterol. Free cholesterol is broken down to H2O2. H2O2 is converted to nascent oxygen, and nascent oxygen has a property of reacting with 4-amino antipyrine to give a pink color solution. The concentration of the pink color or the intensity of the pink color will depend on the concentration of the cholesterol present in the serum, right? So this is the principle, and this is the background of the estimation you are doing. I hope you remember HDL was called as the good cholesterol because it removes the cholesterol from the tissues. LDL was supposed to be called as bad cholesterol, but it has its own value because it takes the cholesterol from the liver and deposits that in the tissue. So the HDL-LDL ratio is very important also, and various like apoproteins are required for all these purposes. After all, HDL is high density lipoprotein. The protein part is called as apoprotein. So the apoprotein plus the lipid part. So all these estimations, estimation of HDL, LDL, cholesterol, triglyceride, VLDL, apoproteins together is called as lipid profile, which is very important for the diagnostic purposes of heart ailments, especially atherosclerosis. Fine. So we'll come to this tray and the measurement proper. I'll show you how the test tubes are being distributed. You take 3 test tubes. Test tube in which serum is being added, test tube in which standard cholesterol will be added, and test tube in which water will be added. It's called as B, it is blank. You adjust the instrument colorimeter with this blank so that the color developed because of the reagents can be minimized. This will have that color of the reagent, which will be here also, which will be here also. We want the color because of the reaction, not because of the colored reagent. So we take a blank so that we can minus it and minimize the error which could have otherwise come. So we have the first addition called serum. We take 20 microliters here, nothing here. Standard, we take nothing here, and we take 20 microliters here, nothing here. And water, and 20 microliters here. So that is how you add the first addition. And then you add the working reagent. I tell you what this working reagent is. This working reagent which you add is 2 ml, 2 ml, 2 ml. Keep this at 37 degrees Celsius, that is room temperature, or for about 10 minutes. In the 10 minutes you will get that pink color depending upon how much cholesterol is present. Standard will give you exactly how much standard is there. And the standard concentration is 200 milligrams. And you take the reading of all these 3 and you use a simple formula: optical density of test upon optical density of standard, then minus blank and minus blank multiplied by 200 will give you milligrams of cholesterol percent. So this is all this is given here. So I don't want to repeat that because the procedure is given to you. And what is this? This is the diluent, and you use the diluent. You take the enzyme vial. This enzyme vial contains both the enzyme esterase and oxidase and peroxidase. So you open this vial and mix 50 ml of this diluent, and it becomes the working reagent. So the working reagent is prepared, 50 ml of working reagent is prepared like this. This is 50 ml of working reagent for you. And this you take 3 test tubes, and in the 3 test tubes they label them as test, blank and standard. In the test tube labeled as T, you will add 20 microliters of serum. In test tube S, you will add 20 microliters of standard, and in blank you will add 20 microliters of water. Add 1 ml of this working reagent, 2 ml of this working reagent in each of these test tubes. Keep it for 10 minutes. After 10 minutes are over, you will get a pink color like this. This pink color can be read in a colorimeter using 540 nanometers, and you will get 3 readings, and that you apply that reading here, or either you take the reading of the blank and minus it here, or you subtract this to the colorimeter itself. So optical density of test upon optical density of standard multiplied by 200, which is the milligram percent of standard value, you will get the concentration of cholesterol. So this is how you do cholesterol estimation. Now HDL cholesterol is done by precipitation method. You precipitate the serum and you see that other LDL, VLDL are precipitated. And when you precipitate LDL and VLDL, what remains is HDL cholesterol. And that you can estimate similarly, same method which we have used for cholesterol estimation here is used. So you get a value of HDL, you get a value of cholesterol. And there is a formula which we will tell you, and that formula gives you the value of VLDL. And these 3, HDL, VLDL, and is done only when you know the estimation, when you know the value of cholesterol. So this is how you do estimation of cholesterol. And you have understood the cholesterol estimation procedure now, and you also know the importance of cholesterol. What are the functions of cholesterol? Cholesterol functions, if you remember what we taught you in chemistry also, in metabolism also. cholesterol functions are, it is a precursor for vitamin D synthesis. It is a precursor for steroidal hormone synthesis, and it is a precursor for bile acid synthesis. It's also a presence, its presence is there in the cell wall, because cholesterol, free cholesterol and esterified cholesterol both belong. And they are from, one is in the pore, and the hydrophilic and hydrophobic amphipathic cholesterol free is present in the outer membrane. So cholesterol is a very important component of the membrane, and it's a very important precursor of many substances. So thank you very much.